Okay.
Hi, I'm Jalen.
And I'm Diego.
This is our hydroponic drip irrigation experiment.
First, let's start with the basics and explain the system that we use. Drip irrigation is a form of a substrate-based hydroponics. So instead of growing plants directly in water like you traditionally would, we're using a growing medium and we're feeding a nutrient solution straight into the roots. And this method allows for very precise control over nutrient levels and watering schedules. And our system was considered an open system, which means that after the solution passes through the pots, it's drained away instead of being collected and reused. And this is important because open systems reduce the risk of disease spreading through that recycled solution. But it also means that you need to stay on top of fertilizer delivery since you can't catch any excess.
So for our experiment, we had 48 plants total, and they were split into 24 and 24. And the first 24 were connected to 125 ppm nutrient solution, and the other 24 were connected to a 250 ppm solution. Everything else was the exact same so that we could compare the yield and the growth. So things like trellising and harvesting the fruit we did weekly, and we also monitored their pH and EC. And did general maintenance like removing suckers and dead material just to keep the area clean.
So to collect our data, we wanted to collect three main types of data. Growth measurements like plant and canopy or plant height and canopy width. We took those every Monday so that we could track that vegetative development, as well as the yield data. The yield data we collected every Monday. We weighed the mature produce on a calibrated scale so that we could calculate the total productivity of each plant as well as nutrient management, which would be pH and EC tests that we did every Wednesday through the pour through method. And we tracked these numbers so that we could so it could help us understand if the plants were absorbing those nutrients properly or if there were imbalances that we needed to address that could cause stress or deficiencies.
So our irrigation, our drip emitters were connected to the dosatron that's connected to our stock tank. So the fertilizer gets released in the irrigation. And we set our timer at the very beginning of the year when it was cooler to 5 minutes of watering every other day. And then as it warmed up, we increased the frequency to 5 minutes daily. And then as it got really hot at the end of the year, we were doing 5 minutes twice a day.
So starting with our results, for the peppers, we interestingly had noticed that the 125 ppm plants had a very early advantage, and they yielded 11.7% more than those 250 ppm peppers, especially during the first weeks. However, the 250 ppm peppers did catch up later on. But those 250 in particular, they showed several signs of nutrient stress. There was brittle stems, branches were breaking off constantly. There was irregular fruit development. And we suspect that this was probably due to over-fertilization, which can weaken plant structure and make them more susceptible to mechanical damage and disease.
In our tomatoes, the 250 ppm yielded 13.5% more. As you can see, around week 5, we have a really big spike in production, and that's due to temperature and sunlight both increasing. We faced an issue with blossom end rot because our tomatoes weren't getting enough calcium originally. And then towards the end, our tomato plants got really big and a little bit unruly, so we had some measurement issues.
Um, with the eggplants gave us the clearest of all of the trends. The 125 ppm side yielded 43% more than the 250 ppm side. So even though both of these groups followed almost an identical growth pattern, as you can see on the graph here, the lower nutrient concentration consistently performed better. pH and EC measurements showed that the 125 ppm environment stayed within those optimal ranges that you want for the eggplants, and that's most likely what gave us that more productive growth. So this highlights that for some crops, more nutrients isn't always better. There's a sweet spot.
Finally, our cucumbers. The 125 ppm yielded 3.5% more when we averaged it. But as you can see, they had a really strong early start compared to the 250 ppm, which had a little bit lower originally, but then steadily increased. Unfortunately, our cucumbers, we only have 6 weeks of data recorded because we actually swapped out cultivars towards the end. Had we been able to keep monitoring this one for the full 9 weeks like the other one, our 250 probably would have been better.
So besides measuring yield, we wanted to track that EC and pH values because they're key indicators of plant health, especially in a hydroponic system, because these measurements help us understand those invisible stresses that plants deal with, like stresses that we might not have noticed just by looking at the plant growth or fruit production alone. So if we start here with the uh, EC, the electrical conductivity, we can see a major difference between the treatments. So the 250 ppm plants had the substrate levels that were consistently about 3 times higher than the 125 group. So as you can see here, we have peaks of about 5 millisiemens versus we have 1.4 for the 125. So high EC means that there's a lot more dissolved roots in the root zone, or sorry, dissolved salts in the root zones. And while salts are good, they because they carry essential nutrients, they can actually cause plant stress when their levels are too high. So this could explain why the 250 ppm peppers and other crops showed signs of physical stress, like those brittle stems and regular fruit that we were talking about. But in contrast, the 125 ppm side had very stable and moderate EC readings throughout the entire experiment. And this stability probably is what helped create that healthier root environment that allowed for better nutrient absorption and therefore better yield. So now looking at the pH trends, so stable pH is crucial because it controls that nutrient availability in a hydroponic system. If the pH drifts too high or too low, certain nutrients can become unavailable to the plant, even if they're technically present in the solution. So in our experiment, the 125 ppm treatment generally maintained a more stable and optimal pH range across all the crops. Peppers in particular had the highest pH um, at for the 125 range, which was still acceptable. In contrast, the 250 ppm group had a variable pH change. Like the peppers pH tended to decrease over time. The tomatoes and eggplants increased slightly, but there were some moments of it going down. This inconsistency could have caused that nutrient imbalance that we were talking about, especially for elements like calcium and magnesium, which are very sensitive to pH changes, which could explain why we were having those issues with blossom end rot.
Some of the problems that we faced. So probably the biggest one is really early on in our experiment, we had some maybe technical issues with our dosatron. Our 1 5-gallon bucket of fertilizer stock solution should last us about a month and change if everything goes right. But we checked in on it and the week wasn't even done and all of our fertilizer solution was gone. So what we think happened was that, maybe the dosatron malfunctioned, but all of our fertilizer was applied at one time and then just straight pure water was watered on top of it and leached out all of our nutrients and really diluted the fertilizer that we needed in the substrate. And this caused our EC levels to fluctuate and they were really unstable to begin with. Blossom end rot, like we mentioned earlier, was a really big issue that we faced. This was just caused because of insufficient calcium, but it would cause the bottom and all through the center of the fruit to rot. So our yield for the tomatoes really early on was almost nothing. As the seasons changed, the temperature spiked, and this caused a lot of our tomatoes to fall early. The cucumbers that we got, they arrived with some sort of disease that didn't really affect crop yield, but it did cause issues with leaf necrosis. The leaves were dying and crumbling up, so we had to stay on top of that because that would be a really good breeding ground for pests. And then speaking of pests, our eggplants had aphids that were a really big issue, but with regular application of beneficial mites and then also a couple chemical sprays, we got those under control.
So ultimately, this experiment reinforced the idea that growing conditions really need to be tailored to each crop's unique needs. because simply increasing nutrient levels doesn't guarantee a better growth. And in fact, it can cause stress if it's not properly balanced, as well as environmental factors like season and temperature and light. They all dramatically affect these outcomes. And growers need to stay flexible and responsive to these changing conditions. Attention to detail, regular monitoring, and being proactive about these adjustments are key for maximizing yield and keeping crops healthy.
And that's our project. Thank
Thank you.
you.